Hello everyone. Today we will be looking at a chemical engineering GATE question, GATE 2015, question number 53. A binary feed consisting of 25 mole% liquid and 75 mole% vapor is separated in a staged distillation column. The mole fraction of the more volatile component in the distillate product is 0.95. The molar flow rate of distillate is 50% of the feed flow rate, and the McCabe-Thiele method can be used to analyze the column. The Q line intersects the operating line of the enriching section at 0.35, 0.5 on the XY diagram. The slope of the stripping section operating line up to 1 decimal place is dash. So this is a question from distillation part in mass transfer, and the reference NPTEL lecture series can be found in lecture 3, week 9, number of trays by McCabe and Thiele for distillation, mass transfer operations 1 by Professor
Hello
B.
everyone.
Mandal, Department of Chemical
Distillation.
Engineering, IIT Guwahati. So
Just substitute it and
let us start with
we
a
have
demonstration of a distillation column.
75% vapor.
So we have the feed
So
F
Q is equal to 0.25,
with its concentration composition XF.
0.25,
Then we have the distillate D with its composition XD, and the bottoms we have the residue W with its composition XW. So here they have mentioned that 25% of the feed is liquid. So that means Q is equal to 0.25. Then they have given us two other data. The mole fraction of the more volatile component in the distillate is 0.95, which is XD is equal to 0.95, and the feed is twice that of the distillate flow rate. So that means F is equal to 2D. So they have also said that the line of the feed intersects the operating line of the enriching section at 0.35 and 0.5. So that means we can write X is equal to 0.35 and Y is equal to 0.5. For enriching section, we have a general equation for enriching section, which is Y is equal to R by R plus 1 into X plus XD by R plus 1. So we have the values for Y, X and XD. So we can just substitute it and we'll get 0.5 is equal to R by R plus 1 into 0.35 plus 0.95 by R plus 1. So here we just have to solve for R. So by solving this equation, we can find the value for R. So solving this, we'll get R is equal to 3. So R is nothing but the reflex, which is equal to L by D, and that is 3. So rearranging this, we can write L is equal to 3D. Now let's go to a condenser balance. So when we take a condenser balance, so this is the condenser, the distillate D, the liquid L and V vapor. So the balance is V is equal to L plus D. So this is the condenser mass balance. So whatever V, the vapor is coming into the condenser is equal to the liquid that is going out plus the distillate that is going out of the condenser. So it is given that the liquid L is equal to 3D. So we can just substitute it and we can write V is equal to 3D plus D, which is 4D. So they have given feed is 25% liquid and 75% vapor. So Q is equal to 0.25. So now let's go to a feed tray balance. So we have the feed F coming onto a tray and we have the incoming liquid L from the enriching section and the L dash L bar going to the stripping section and the V bar coming from the stripping section and V going out of the tray towards the enriching section. So if we can write a balance for this feed tray, we can write these equations. L bar is equal to L plus QF, V bar is equal to V minus 1 minus Q into F. So this equation, it is nothing but L bar, which is the liquid that is going out of the feed tray, is equal to L, which is the liquid coming into the feed tray, plus Q into F, which is the fraction of liquid that is coming into the tray from the feed. Similarly, V bar is the vapor that is entering the tray, which will be equal to the vapor V that is going out of the tray minus the fraction of vapor in the feed, which is 1 minus Q into F. So we can substitute these values. We have L is equal to 3D. So we can write L bar is equal to 3D plus 0.25 into F, and F is also given as 2D. So 3D plus 0.25 into 2D. So L bar is equal to 3.5D. Similarly, we can find V bar as 4D minus 0.75 into 2D, which is 4D minus 1.5D, and V bar is equal to 2.5D. Okay. Now, slope of the the stripping section is nothing but the ratios of the molar flow rates of the liquid to the vapor. That means L bar by V bar. And we have the values for L bar and V bar. So slope is equal to 3.5D by 2.5D. We can cancel out the D and we'll get 3.5 by 2.5, which is equal to 1.4. Thank you.